Hi everybody. I'm going to tell you some things about parallel lines and proportions. It's a pretty tough little exercise. Stay with me. Just generally speaking ahead of time though, if I had a triangle and I passed a line parallel to one side of it, let's agree that these sides are parallel. Why would you get proportions? And the thought should be that this angle would be congruent to that one. Those would be corresponding angles. They would be congruent. And this one would be congruent to that one. And it turns out that this upper triangle would therefore be similar to the large triangle, and since the triangles are similar, their sides are in proportion. There's lots of ways you could work with that with addition and subtraction, and you could get interesting proportions. And we're going to go right to doing that right now. So looking at this first one, let's put some lengths in place. We understand that PQ, it says, is parallel to BC. Label AP, this upper length is x plus 4. And that full length AB, the full side here, is 2x plus 4. We're going to have to find out about that bottom length in a moment, I think. AQ on the right-hand side is 3x plus 2. And QC is just 12. A good simple proportion that consistently works is upper section is to lower section as upper section is to lower. But that's going to require that we know that length right there. I don't think it's going to be too hard. What do you got to add to x plus 4 to make it be 2x plus 4? Yeah, that length's just got to be x right there, doesn't it? And I'm just going to stick to it and set up a smooth, small proportion here. X plus 4, that upper length on the left, is the lower length on the left, x, as, and on the right, what would follow? Upper length 3x plus 2 is the lower length 12. And here we go with our proportion. What you do with a proportion is you cross multiply. Let's do the product of the means first. 3x plus 2 times just x itself would be 3x squared plus 2x. And multiplying the product of the extremes would be 12x plus 48. I'm going to bring everything to the left-hand side where the squared term would be positive. That would give me 3x squared. And as I subtract 12x from both sides, minus 10x. Bring that 48 to the left-hand side, minus 48 equals to 0. And that's what we got to factor. That's a 10 right there, and kind of hard to see. I'll bring it up there and set that up again. That was 3x squared, sorry about my handwriting, plus minus 10x minus 48 equals 0. Throw out a couple pairs of parentheses, please, and let's see what we can do. I'm looking for the factors of 3x squared. That's going to have to be a 3x and a 1x. Now I've got to get the factors of 48. They'll fall here and here. That's easy to find. 4 and 12 would work, 2 and 24, maybe 6 and 8. But I got to get that 10 in the middle. And what occurs to me is if I put a 6 here, that would give me 3 times 6 is 18x. And if I put an 8 there, 8 times just x would be 8x. A positive and a negative. If I made this be negative there, a negative 18x would make this one be positive. And a positive 8x would give me that negative 10x in the middle. So I'm thinking that's the good factorization. You could check it though. Let's set those factors equal to 0. The first one on the left is 3x plus 8 could equal to 0. That means that 3x is equal to negative 8. That'd make x equal to negative 8 thirds. That'd be like negative 2 and 2 thirds. That'd be no good because this length had to be x, and we deny that lengths can be negative. So that's an erroneous root. But on this other one, x plus 6 could equal to 0. And that would force me to think that x, oh, excuse me, that was wrong. That was x minus 6 could equal to 0. Therefore, x must equal to positive 6. Now that I have what I think is the good root, the valid answer for x, I'm going to sketch this again and throw in some lengths that I can figure out. Knowing that x is equal to 6, this top part would have been 6 plus 4, just 10. The bottom part here is just 6 itself. On the right hand side, 3 times 6 is 18 plus 2 would be 20, and the lower length being 12. Maybe you can see this is a pretty good looking proportion. This 10 doubles to be 20 and that 6 doubles to be 12. So I'm saying, yeah, we got everything working so far. I'm liking that route. But here comes a clever little part right here. It tells me on the left over here that if PQ, that segment across the middle, is 4x plus 1, which would be 4 times 6, 24 plus 1, that'd be 25. Find this length down here. PB. Yeah. Oh, excuse me, well, it should say that length. I'm looking for BC right there. It does say PB here. But I'm looking for that lower length, I know. I'm going to call it X. An interesting thing happens here. The only way you can get that, well, there's a couple ways, but they're going to both be generally the same. I'll show you them both. 10 is to this horizontal length 25 and you have to go to the full length here now, which is 16, is to what we would call X. You could go from the right-hand side. That would be 20 is to 25 as 32 is to what we would call X. But let me work this one, and I'll work it both ways soon enough. Cross multiply. The product of the means, 16 times 25 is 400, is equal to 10 times X. I'm going to divide both sides by 10, and I'm pretty sure that X would have been 40 there, huh? So with that thought in mind, I would report that BC is 40. We don't got to check everything 11 times, but I just want to take a look at this with you. What if I'd gone from the right-hand side and said 20 is to 25 as, got to go with the full length, 32 is to X. And if you cross multiply it here, what would happen? I think 32 times 25 is going to be 800. You check that with a calculator, though. Makes sense to me. 4 times 25 is 100, and I got 4 times 8 there, so that'd be 800 is equal to 20x. Divide both sides by 20, and yeah, I'm pretty convinced that x was equal to 40, that BC, that bottom length, was 40. Let's jump on the next one, see what we can do. I'll try to be a little more careful. I'm told that AB is parallel to PQ. I've given some lengths. RB, let me start up here. AR, x plus 6. PR, that full length there, x plus 15. RB, this part is 2x plus 2. While BQ, the lower length, is x plus 3. I'm going to need to find out this part right there, aren't I? Actually, you could do this different ways. I could find that full length there. I would just have to add those up. And if you did do that full length, it'd be 3x plus 5. Well, it would be perfectly fine to know that this part would have to be 9, because if you added 9 to x plus 6, it would give me x plus 15, and you could have worked it that way, top is to bottom as top is to bottom. But I want to show you lots of different proportions. I'm going to go with the top part here, x plus 6, is the full length on the left, x plus 15. And since I went top is to full, you'd have to go top is to full on the right. That would be 2x plus 2 is to 3x plus 5. Let's go, see what happens when we cross multiply. Find with me the product of the means. First term times first term, 2x squared. Well, I'll do the outsides and the insides together. Outsides give me 2x, insides give me 30x. Therefore, we have a positive 32x. And last times last, 15 times 2 is just 30. The product of the extremes coming now. First times first, 3x squared. Outside terms give me 5x. Inside terms give me 30x, excuse me, 18x. I'm looking at other things. 18x and 5x, there's 23x, huh? And last times last, 30. let's set that equal to 0. 0 equals, going to bring everything to the right-hand side, and I would just have 1x squared. And if I subtract 32x from both sides, 23 minus 32 leaves me a negative 9x. Bring that, oh, look at this. When I bring the 30 to the other side, they add out to 0. So this is what I got to work with right there. You might be saying, well, can I factor that? It's not a normal trinomial like we factored over here, but it certainly can be factored. The thing is that x is common in both of the terms. So 0 is equal to x times something. And that would just be x plus 9, excuse me, x minus 9. And if we multiplied that, we'd get that back again. So I'm thinking x is either equal to 0 or x minus 9 is equal to 0. And I'm going to go with x is equal to 9. Actually, that x equal to 0 is kind of an interesting thing. Let me take a look at it for a second. Just going to sketch this thing and say, what would have happened with x equal to 0? I think it's probably valid. I'm just going to sketch that triangle on another piece of paper. See what happens. If x were really 0, this would have been 6, huh? 0 plus 6 is just 6. The full length was x plus 15. 0 plus 15 make this full length have to be 15. This part would have been 9, because those add up to 15 together. And if x is really 0, this part would have just been 2. And this would have been 3. And that's a valid proportion. 6 is to 9 as 2 is to 3. So I'm liking that okay. I think that x equal to 0 would have worked. Although it is a funny number, I'm going to go with this other root. I think that's the one we really care about. I'll make a quick sketch. Throw in the lengths that I'm aware of. If x is truly 9, this top part would have been 15. The full length would have been 9, x equal 9, 9 plus 15 would be 24. And if that's 24 and this part's 15, wouldn't this be 9? That adds up correctly, doesn't it? Upper part on the right is, that next be 9, that's 18 plus 2 would be 20. And then 9 plus 3 here would have been 12. Kind of a clever thing to do is I'm just going to see that these things are proportional. That is that 15 is to 9 as 20 is to 12. And I can see that that's 180 and that's 180. So yeah, so far so good. We got a good proportion. Here's the kind of the cute part. It tells me if AB is 20. AB is this second across the middle. If this length is 20, what about that section right there? We're going to call it X. Now I'm going to approach this a couple of ways. They ought to agree. I'm going to come from the left the first time up. What if I went with 15 is to 20 as the full length here, got to go to the full length as we compare these sides, as 24 is to X. Cross multiply here, and 20 times 24 is 480. It's equal to 15x. Divide both sides by 15. And x would be, well, how many times 15 goes into 480? And I think that's going to be 32. You check me that with a calculator, but I'm believing it's going to be 32. And I'm happy with that. I think that length could have been 32. I could have approached it from the other side. What would happen if you did? I think it's kind of interesting if I do. Let me do that. It's probably a good idea. Let this be 15, and this is 20. This is 9, and this is 20. And this was 12. And if I approach it from the right-hand side, 20, this length 20 is to this length 20, as this full length 32 is to what I'm looking for. Yeah, that'd have to be 32, huh? That's a 1-to-1 relationship, so this would have had to been 32, which does agree with what I thought a minute ago. But here's another interesting thing. If this thing is isosceles, this is 20 and this is 20, wouldn't the big one that's similar to it also going to be isosceles? This is 32 and that's 32. So it makes sense to me that would have to be true. There's a lot more to do. Let's throw in these numbers and burn this baby down. PC is x plus 5. AC, that full length there, is 2x plus 4. QB, the lower length on the right is x plus 2. And CB, oh, the whole darn thing on the right hand side is 3x plus 6. Now we could figure lots of different ways to do this. It'd be good if I knew this lower length, and I go top is to bottom if I could find that top length there. And I think both of those are available to us. What would be this lower length across here? If you subtracted x plus 5 from 2x plus 4, or if you think, what do you got to add to x plus 5 to make it become 2x plus 4, I think it'd be x minus 1. Isn't it true if you add those up, x minus 1 and x plus 5, you get 2x plus 4? Same kind of thing over here. What would I have to add to x plus 2 to get that 3x plus 6? 2x plus 4? Lots of things you could try here. You could go top is to bottom, as top is to bottom, perfectly valid, works like a charm. But what if I said the top part, x plus 5, is to the full length on the left, 2x plus 4. Show you what I'm writing. And I went, top part is to the full length, so on the right hand side you say the top part 2x plus 4 is to the full length 3x plus 6. You know, this is just an example of a valid proportion. There are lots of them. I did top is to full length as top is to the full length. And that should work. Let's go for the product of the means. That's kind of an interesting product. 2x plus 4 times 2x plus 4. Yeah, that'd be 4x squared. Outside terms 8x and the inside terms 8x plus 16x plus, and 4 times 4, 16. Should equal, now let's get the product of the extremes. This one and this one. I don't need the parentheses. There. 3x squared. Outside terms 6x. Inside terms 15x. 3x and 5. So 6x and 15x, that's 21, I think. Yep. 21x. And last times last plus 30. And let's set this bad boy equal to 0. I'm going to subtract 3x squared from both sides, just leaving x squared here. I'm going to subtract 21x from both sides, and that would leave you with a negative 5x. I'm going to bring that 30 to the other side, and that would become a positive 16. Take away 30 would be a negative 14. Feeling better about this? I think it's going to factor just fine. Let's factor it then. Factors of x squared, x and x. About the factors of 14, 7 and 2. Can you get that 5 out of that 7 and 2? Yeah, I guess you could. I know that that 7 times that 2 gives me a negative 14, so one of them's got to be negative. I want that middle term to be negative. Put a minus sign there. When I multiply the inside terms, I get a negative 7x. If I put a plus sign here, and I multiply those, I get a positive 2. And a negative 7 and a positive 2 give me that negative 5. Last times last, a negative 14. Properly factored, you say. Let's set those factors equal to 0. X plus 7 could equal to 0. Or x plus 2 could. So either x is equal to, ooh, that was x minus 7. I apologize. Let me fix that. X minus 7 could equal to 0, forcing x to equal positive 7. Or x is equal from the other one. Other factor, x equal to negative 2. That can't be the negative 2. That would make this length AP be negative 2 minus 1. That'd be negative 3. I deny that. But I like the x plus 7. Came from the factor x minus 7 was equal to 0. So I'm going to go with x equal to 7. I'm going to make a quick sketch. Makes things a little bit easier if you do. We'll let x equal to 7. And that upper length would have been 7 plus 5. There's 12. The lower length would have been 7 minus 1, that's just 6. Upper length on the right hand side would be 2 times 7, 14 plus 4 would be 18. And on the right, the lower right would be 7 plus 2, which is just 9. If you look at this with me, you might be thinking, well, that 12 is twice as much as 6, like that 18 is twice as much as 9. So I'm thinking, hey, we got a good looking set of proportionate numbers here, don't we? But the clever part is, it tells me that PQ is x plus 3. I'm knowing that x is equal to 7, so PQ, this length had to be 7 plus 3, that'd be 10. Now let's find this lower length across here, which I'm just going to call x for right now. You could do it from the left or you could do it from the right. You go from the left, I'll go from the right. 18 is to 10 as, got to add those up, and I get 27 is to x. I'm going to cross multiply and go, and 27 times 10, 270 is equal to 18x. Divide both sides by 18. I think this is going to go smoothly. I think 18 goes into 270 15 times. Check that with a calculator, but I'm pretty sure it's true. X is going to be 15. So I can conclude safely, I think here, that that AB is 15. That's AB is 15 right there. Okay, let's get that length right there. Had to have been 15. Let's go to that second page. There's even more fun to be had. More parallels, more quadratics coming your direction. PS is 2x plus 2. PR, that full length there, is 3x plus 6. RT, the upper length, is 2x plus 2. Well, the TQ, the bottom part, is just 16. Lots of things are available. I could say the bottom part is the full length, as the bottom part is the full length. But I think it'd be kind of good for us to figure out, what's this upper segment right there from R to S? What would you have to add up? 2x plus 2 to make it be 3x plus 6. I think x plus 4, huh? Yeah, if you add those up, you get 3x plus 6. And let me just stick with a really simple proportion. Upper segment is to lower, as upper segment is to lower. X plus 4 is to the lower length 2x plus 2, as the upper side on the right is 2x plus 2 again. How about that? Is to the lower length 16. You can switch the means on that proportion, wouldn't change it much, huh? This length is to that one as that part is to that one. Let's see what happens when we go this direction. What's the product of the means? 2x plus 2 times 2x plus 2, 4x squared plus 2x, 4x there and 4x there plus 8x plus, and 2 times 2, just 4. You might want to write those out rather than just cross multiplying. That'd be okay. But now what about the product of the extremes? Yep, these are the extremes. That'd be 16x, and 16 times 4 is 64. Let's set that equal to 0, see what comes. I'm going to bring everything to the left-hand side, leaving 4x squared. And as I subtract 16x from both sides, I got minus 8x there. And if I subtract 64 from this positive 4, that'd be a negative 60, huh? And I seek to factor this, but what we should be thinking is, hey man, 4 goes in all of those terms, doesn't it? Let's pull off that common 4. 4 times some things, that'd be 4 times x squared minus 2x minus 4 times what gives you 60? That'd be 15 right there, is equal to 0. And that's what we want to factor. Let's make that happen. Throw a couple of pairs of parentheses, then we'll fill them up. Looking for the fact, well, I should keep the 4, although it won't be a player, but just for good form. The factors of x squared, got to be x and x here and there. Looking for the factors of 15, probably going to be 5 and 3, aren't they? And we can get that negative 2 if we're thoughtful about it. Make the inside product be a negative 5x, the outside product be a positive 3x. And wouldn't that give us the negative 2 in the middle? You multiply those and be sure you get this back again. I can see that we would. If the product of these factors is equal to 0, one of them's got to be 0, and it's not going to be the 4. But I'm thinking x minus 5 could be equal to 0, or x plus 3 could. So now I'm thinking either x is equal to 5, or maybe x is equal to negative 3. How about that negative 3? I don't think it's any good, because 2 times negative 3 be negative 6 plus 2, make that length be negative 4. I deny it. I'm going to go with x equal to 5. Going to make a quick sketch. Going to throw in the numbers I know. X is 5, so this would have been 5 plus 4 would have been 9 there. The lower length would be 2 times 5 is 12. 2 times 5 is 10 plus 2 would be 12. This would have also been 12 for that same thought. And this is 16. A couple things you might be thinking about ahead of time. Is this proportional? Yeah, buddy. 9 is to 12 as 12 is to 16. Hit that with a calculator, but I'm knowing that 9 times 16 is 144, so is 12 times 12. So, hey, got a good looking proportion there. It tells me that ST is 2x. This segment is 2 times 5. That must have been 10. So what must this length of be? We'll find a PQ, won't we? Approach it from the left or the right. I'm going to go from the left. 9 is to 10. This side is to 10 as that full length 21 is to x. Yeah, I'm going to get some ugly answer here. I think 10 times 21 is 210 is equal to 9 times x. 9x. Divide both sides by 9. You know, one thing that comes to my mind right there, 3 goes into both of them, so that'd be the same as 70 over 3 is equal to x. And 70 divided by 3, I'm thinking that's going to be 23 and 1/3. You divide with the calculator, I think it's 23 and 1/3 is the value for x. But I'm not liking that number so much, so I think I'm going to approach this again, maybe from the right-hand side. You come along and check me out. How about if I did 12 is to 10? As the full length here, 28, is the part I'm looking for, x. See, when we cross multiply in here and everything, if we don't get that same 23 and 1/3. So 28 times 10 is 280 is equal to 12 times x. 12x there. Divide both sides by 12. You can hit it with a calculator. That's life is easy there. But if you think about this with me, 4 goes into both of them. 4 goes into 280 70 times, and 4 goes into 12 3 times. So, hey, how many times 3 go into 70? Yep, that's going to be 23 and 1/3, isn't it? So I'm sticking with it. I'm thinking that's a valid answer. That's what that lower length, I should call it PQ, is equal to 23 and 1/3. Let's play some more. Couple more to do. DE is 2x plus 4. DA, oh man, the full length, huh? Is 3x plus 9. DC is 15. And CB, this lower length, is x plus 3. You could find this length, I think it'd be x plus 5. Because that way you could add those up to this. Or you could do this. Let me just play another way of looking at this. That full length would have been, add those two things up, that'd be x plus 18, huh? Let me get that in place. X plus 18. And I just want to exhibit different proportions that are available. How about if I went to this upper length, this is the full side, 2x plus 4 is to the full length there, 3x plus 9. What would follow there? And since I went upper length, this is the full length, you'd have to go with upper length is to the full length again, as 15 is to x plus 18. Let's see what happens when we cross multiply here. The product of the means first. 3x times 15 is going to be 45x plus, and 9 times 15 is 135. What about the product of the extremes? Carefully here. 2x times x is going to be 2x squared. Outside terms, 2 times 18 is 36x. Inside terms are positive 4x. 36 and 4 is going to give me 40x. And last 4 times 18 is 72. I got to set that up equal to 0. Going to bring everything to the right hand side. I don't have a square term to bring over, but I'm going to leave nothing behind. Going to leave 0 on the left. I'll keep the 2x squared that I have, but as I subtract 45x from both sides, 40 take away that 45, leaves me with a negative 5x. And when I bring that 135 to the other side, you got to think 72 minus 135. And I think that probably, Alexa, what's 72 minus 135?
72 minus 135 is minus 63.
Minus 63. Okay. Nice to have Alexa around, isn't it? I'm going to see about factoring this boy. Throw out a couple of pairs of parentheses. Factors of 2x squared, going to have to be 2x and 1x. Now about the factors of 63, I'm thinking 9 and 7 are pretty good looking factors. I got to get that 5 in the middle. Makes me want to put a 7 here so I could get 14x. 7 times 9 is 63. I got to put that 9 there, and that would give me a 9x and a 14x, and a 9x give me that 5. Make that 14 be negative. Then 9 times 1x, make that 9 be positive. If you check that factorization, I know it gives me 2x squared minus 14, but plus 9x gives me the negative 5x, and last times last a negative 16. We factored it well. Let's set those factors equal to 0. 2x plus 9 could equal to 0, or x minus 7 could. In this case, 2x is equal to negative 9. Therefore, x itself would be negative 9 over 2, like negative 4.5. I don't think that's any good. Negative 4.5 plus 3 being negative 1.5. That's a dismal root. That's an erroneous root. But would x minus 7 equal to 0? Now I'm convinced that x is equal to 7. With that thought in mind, let's throw a couple of things in place and see what we can find. Show that parallel. Now let x equal to 7, and 2 times 7 is 14 plus 4. That'd be 18, huh? And the full length there should have been 3 times 7 is 21 plus 9 would be 30. What do you think about this little length right there? Yeah, it'd have to be 12, wouldn't it? That way they add up to 30. On the right-hand side, this length is 15, and the lower length is 7 plus 3, therefore 10. Just going to look at this with you. I think probably something we ought to all be thinking about. Is it true that 18 is to 12 as 15 is to 10? Yeah, I like it. Going for the product of the extremes is 180. The product of the means, 12 times 15, is also 180. So I'm happy with that. But if we know this length right there, it tells me that EC, that length is 2x plus 1, but I'm thinking x is 7, so 2 times 7, 14 plus 1 makes that one be 15. What would this length have to be? I'm going to go from the left. You might see something ahead of time, but let me approach it from the left. About 18 is to 15, as the full length 30 is to what I'm looking for, x. 15 times 30 is 450 is equal to 18x. Divide both sides by 18. I'm going to ask Alexa maybe, but I'm also thinking, you know what, 9 goes into both of those, isn't it? That's the same as 9 goes into 450 50 times, and 9 goes into that one 2 times, so that's going to be 25, isn't it? Yeah, I'm thinking that length should have been 25. Here's another thought you might be considering. Let me just take a look at this with you. Just that same thing, just considering it had I approached it from the right-hand side. This length was 15, and this length was 15. This small triangle is isosceles, isn't it? Makes me think that the big triangle would have to be isosceles. And this full length was 10 there, so therefore 25. Makes sense that this would have also been 25. Yeah, those two sides are congruent. These two sides ought to be congruent as well, so that lower length would have been 25. So I'm happy to stick with what I thought of here. One more time, guys. Let's do this other one. TP, this lower length is x plus 2. PS, well, that's the full length, isn't it? Is 2x. SR, this upper length is x plus 1. Well, the lower length is 2x minus 1. A couple things are available. You could say the lower length is to the full length as the lower length is to the full length. I'm going to keep it simple. What would this upper length have to have been? What would you add to x plus 2 to get 2x? I think that'd have to be x minus 2. Wouldn't those add up to 2x? I'm pretty sure they would. So now, There are a mountain of different proportions that you can set up, but I want to keep it simple on this last question. Top is the bottom as top is the bottom. That works every time. X minus 2 is to x plus 2 as, and on the right, x plus 1 is to 2x minus 1. Top is the bottom as top is the bottom. Yeah, that's a valid proportion. What would be the product of the means? You got to get good at multiplying these binomials, huh? First times first gives me x squared. Outside terms is 1x, inside terms is 2x. That gives me 3x. Last times last. That's just 1 times 2, going to give me 2, huh? What about the product of the extremes? Let's multiply those. And x times 2x gives me 2x squared. Outside terms is a negative 1x. Inside terms is a negative 4x. Together that's a negative 5x. And last times last a positive 2. Let's set that bad boy equal to 0. I'll take everything to the right hand side. And I would have a positive 1x squared. Bring that positive 3 to the other side. It gives me a negative 8x. And that positive 2 knocks off that positive 2. So I don't have a trinomial. I don't have 3 terms to factor, but I got 2. Pull off that common x. X times some stuff would give you that back again. That had to be x minus 8, wouldn't it? So I think if the product of these two factors is equal to 0, one of them's got to be equal to 0. So either x is equal to 0 or x minus 8 is equal to 0. Therefore, x would equal to 8. Is this root erroneous? Yeah, I'd make this link be negative, wouldn't it? 0 minus 2 would have been negative 2, so I deny that root. I'm going to go with x equal to 8 and just make a quick sketch. Throw in the links that must be true. If x were truly equal to 8, this upper part would have been 8 minus 2, just 6. And 8 plus 2 would have been 10. 8 plus 1 would have shown me a 9 there, and that lower length, 2 times 8 is 16, minus 1, 15. Let me just check on that, see if it's proportionate. 6 is to 10 as 9 is to 15.